this phase of the simulation, we need to understand the target network we compromised. This is the target client, and we don't know anything else. So we need to collect information. We have discussed about some of the information collection techniques previously. They were called situational awareness techniques. They are simply used to get system information, user information, collecting sensitive files, credentials from the browsers, screenshots, and some additional tools or useful information that we can reutilize against the target network. In this example, our target network has two systems. As we described this in our previous videos, these two systems are actually metasploitable. So Windows 2008 and Ubuntu Linux 14 are used as two servers representing two critical functions here. The first one is application server, which represents a financial application in a large financial institution. That could be Swift application, for example, but I will use payroll application as a replacement and running on this metasploitable tree. Also for Windows section, Windows could be any system in the large organizations as well. They may have lack of patches, lack of secure configuration or hardening, and we can compromise them slightly easier. Of course, we need to find them as well. And we have different scanners in Metasploit or in our tradecraft to understand what systems are vulnerable. In this case, we use Windows 2008 Metasploitable tree to represent that Windows server. So it has some vulnerabilities and non-vulnerabilities. Previous videos, we have acquired also our system token. And system token is represented to Metasploit. We have now 4 sessions here, 4 metaoperators running with different tokens. And 3 of those are system, and 1 of those is user token. So let's focus on what we can do with that. When we use the token, the sessions, for example, the session 4, we can collect some information from the remote system. In this case, sysinfo will help us. If we use ifconfig is an internal function on metaoperator that gets the network information from the remote system, just like the ipconfig running on the remote system. There were 2 networks connected, and we have identified that this is the local network. This can be identified using several different ways, but in our case, it is slightly easier because our environment is based on the first network address. So this is the Kali Linux network. So 172.16 network is Kali Linux. That means the client is connected to the Kali Linux network, but the second network is isolated. Logical diagram will be like that. The left is the Kali, and this part is the target network. The blue ones are representing the private network, and the red ones are the network connected through internet, through some proxies and secure gateways. Now we need to understand this network. So I copy and get this done and go back to our main menu. And this time I use route add command to add a route to a session. In this case, I will use the first session. The command is adding a route specifically for session 1. Whenever Metasploit modules will try to reach this network, all these modules will tunnel their traffic through this metaoperator session. That means the employee laptop will be used to tunnel the traffic to the other servers, which is quite useful to run different tools on Metasploit easily. For example, HTTP version is a good scanner that can identify the HTTP services running in the remote environment. For the remote host definition, we can give a certain range. The parameters are available here. But for our hosts, I used only a range of 2 and 3 because it will take time and I need to use one thread for now to not crash this metapreter session. Even though I have backups, probably that metapreter session won't be efficient just like on a real network. That's why I will use just one thread. And for all attempts, for more than 200 systems will take ages. Instead, I will narrow this down to the systems we already identified. This can be also performed with small chops in the target network in a real exercise as well, because we don't know whether or not there is a network monitoring tool which can identify our port scanning attempts. I run this, but before that I enable the verbose mode so I can see whether or not any errors or anything else happening. Okay, good news. We have some web services running on the remote systems. So this is a useful information set for us. So we can get more. So we can do a lot of different things against those web services. But we also identified that those two systems are our targets. And one of those is Windows. The second one is Linux. It's Ubuntu. So if we go back to our main menu, we can identify another thing here as well. Search SMB version. That's another module that we can use to identify the Windows version and some additional information. So our host range can be still here and verbose can be set true and we can run it against those two systems. Most of the Windows systems won't be firewall protected in local networks. The problem there is whenever they implement the firewall needs to have an exception for the port 445 or 139, which are the NetBIOS and CIFS ports for Windows systems. So eventually 445 will be a good port to scan the entire network to identify the systems. I use SMB version here because SMB version simply connects to the Windows 139 445 ports to get the system SMB version. It is useful for Windows, but for Linux Samba even, it gets some information. This host is running Windows 2008 R2 standard build with this parameter. The host server name is Metasploitable and it doesn't belong to any domain. I didn't provide any Active Directory environment, which is not easy to run low-level hardware laptops. So it's quite actually enormous power. That's why I use standalone servers. And the second one is also identified as Samba. So host could not be identified, it says, and it receives this number through the SMB version presented by Samba. But Samba in the host name also leaks its version. So we can build some attacks on this. So the first attack in my mind will be quite aggressive, but also useful. If we know that equation group leaks, the shadow broker leaks, we also know the Eternal Blue, which is a famous exploit. But there's also some sisters to those exploit sets, so Eternal Romance and more. If we search for Eternal, we can see some of those modules are already ported to Metasploit, so we can use them. But remember one thing here. Our Metasploit framework and Metapreter is running on the employee laptop, so those remote systems are not compromised. So we will tunnel this through. It may work if we are lucky, but sometimes we are not lucky because the network may have delays and the brute force will fail or timeouts will occur, or moreover, there is a Windows Defender or EDR running on the system. To avoid this kind of challenge, we can look for most reliable exploit for the target environment. Eternal Blue will be reliable, but also there is another one right here, and it is also called Eternal Romance or Eternal Synergy, Eternal Champion. So this is a kind of stable exploit, and I can use this one against the Windows, and we can see whether or not it will work. And the target host is the given host, and let's see the options. If this fails, we can always call Eternal Blue. Those systems are running here, so we can compromise them and we can see what's going on here. And I'm taking a snapshot of the Windows in case of we crash some service, so we can just simply get it back. So show options of this Eternal Romance gives us some details that we can customize. For example, name pipes. If the server requires username, we can adjust this as well. And finally, the reverse TCP. The reverse TCP is not the way we can do, because those servers won't have access to us. We need to have access to them. That's why we shouldn't use reverse connections, any reverse. We need to use bind. So the server will have a metaoperator service running there. So we will connect to it. It won't connect back to us. That is most important setup here. So setting payload as bind TCP. And also adjusting the port. We can leave the port like that for now, but remember that if the firewall is in place, you need to also verify that that port is accessible. In this case, I tried to make things smooth. That's why I avoided more trouble here, because it is already complicated. And we are this time targeting the host. The port is default 4444 and bind TCP, and we will compromise this system using this payload if we are lucky. Remember that our route is here. It is based on session 1, and the session 1 is the NT authority system token running metaoperator session. So let's exploit and see whether or not it will fail. If we have option fails or network fails, that will be okay. And in our next video or videos, we will fix this and we will try it again. Let's use exploit. It will be too slow. The reason behind of it is there will be tunneling. Sometimes it fails just because of the configurations. So this exploit won't work. So let's go back and search for another Eternal and go for Eternal Blue. Eternal Blue is also Windows 2008 and R2. And I can add the same settings for it. Our host is set here. Payload is bind. And let's see the options before running the exploit. It will require the IP address, our port. Architecture verifications will be done. And it is right here. So I hope this exploit will work. But if we crash the SMB, we will also know this. But Eternal Romance did not work well. So let's see Eternal Blue would work. It is running a check. It says that the patch is missing, but this, even though this is a good sign, good indicator, we don't know the exploitation will be successful because it is quite fragile. So it says that Eternal Blue override completed successfully, starting bind TCP handler against 172.128.2 and port 4444. This may also fail just because of this port, because this port will be busy or inaccessible, or while we are trying to connect this port um, will be um, delaying in this context. So we can try it again until the server may crash. This is how Eternal Blue works. That's why it's not suggested for the production environments. Exploitation, especially memory corruption exploits, are quite fragile and unstable. So you need to play with it quite carefully. Sometimes the challenge is not only designing the exploit or payload, sometimes it is only making the service, actually keeping it alive, not only hijacking the application flow to get the code execution. It's only giving you momentarily application flow to run your code. But if you keep the application alive, you will have a reliable exploitation attempt. Again, Eternal Blue is a quite complex exploit, so it has these issues, and the first attempts are generally not successful. On the good news, the SMB service is still responsive, so we are not getting any fail regarding the service itself. So we don't know whether or not this system crashed. It appears so. It's not crashed, but the exploit did not work well. So we need to find another way to do that. Let's go back and search for other eternal exploits. Let's see whether or not the other ones will work. Maybe we should change our way. For example, our sessions were simply also responsive, and we are on the client, right? Which is the employee system, this one. What if we get the credentials? That could be quite useful, right? The thing is, MetaPreter and its attempt for the credentials are not always great. That's why we need to use some features of it and to see whether or not it works. I'm using MetaPreter using Kiwi and load Kiwi and then Kiwi help. And let's see, Chris all will work. It may trigger MC, but it gave us the NTLM hash anyway. So I'm going back. And this is our NTLM hash. And let's put this for another type of attempt. And we can see maybe that user has administrative privileges to run some commands or do some stuff. So we have some psexec command as auxiliary before jumping to the exploitation. Let's see that this user has code execution rights or not. So simply it will list the domain admins on the remote system as command. So we can add a different command here. So we can make it running if it runs exactly. So setting the remote host is the first step. Setting the user. Reader. Setting the assembly password is our hash. Let's exploit. Actually, run is more suitable because it's an auxiliary module and it won't generate any shell. Logon failure. So we need to find another exploit for this one. So Metasploit 3 has different exploits for Windows. So we need to find those exploits and we can just run all of those. There are some resources here, so we can reutilize these resources and we can use any of those. For example, this one. We can use these walkthroughs to find the Windows exploitation. But we know a couple of things here. First, we have users. Second, we have access to this system remotely, and we tunnel the traffic through our session, and it is accessible. Now, we need to investigate what vulnerabilities could be done. And I need to stop the video here. So these vulnerabilities and simple exploitations will be a different video and a different setup, and I will demonstrate all of those here.